Okay, creating hidden rooms. So there's actually two components to this that are used in conjunction, but are not strictly related, and that is the actual hidden room and the destructible walls. So you can see this portion of the wall right here is slightly darker, and you can jump off of it, but if we dash into it, the wall breaks. When we go in here, the secret hidden room is revealed. So, how I implemented this, I'll go over the destructible wall first since it's simpler. Um, Unlike the rest of the tiles, this is actually not on my tile map. I decided to just create these as objects, and I haven't optimized this at all yet. These aren't prefabbed or anything. I was just testing it out. I just changed the color, and I placed them in the correct location, and then attached a script to them. So destructible walls, and when the player collides with the wall, and if the player's dashing, then destroy. So that's that. Obviously, I'll make some changes, probably make it, visually not just instantly destroyed. Some animation. Um, there are some bugs, not bugs, but you don't have to dash directly into the wall. If you dash like up the wall, it will destroy it, which I don't want. So I'll be tweaking it, but that's the most basic implementation of that. Now on to the secret or hidden rooms. So it starts out with the actual hidden room tiles. So the hidden room is built on its own tile map, which I have named hidden rooms, and it's tagged so I can easily reference it. You can see all the tiles there. And then there's a hidden room object. So I would create all of the hidden rooms on a level would be on the same tile map, but I would create a new hidden room object for each room, and I would prefab this. And basically this has a couple of colliders on it and a script. So the box collider is meant to be used as a bounding box for all of the tiles that will be in the hidden room. So obviously this implementation only works for rooms that would fit into a box, right? If it's some huge winding room, if you can put a box around the whole thing, great, but if it like intersected with other parts of your level, then maybe this implementation would need to be changed. But for my uses, this is good enough for now. So this will be used as a bounding box, so we can find all of the tiles in the room that need to be hidden and revealed. As you saw at the start, they are hidden. You cannot see the tiles, and then they are revealed. So the second collider, which is just this edge collider here, is just simply used as the trigger to reveal the tiles. So if we go over to the secret room implementation, the script, you can see we have the tile map, and we have the box collider. And what we need to do is to hide all of the tiles, we need to set their alpha to 0. Because the tiles are still there, we just don't want the player to see them until they've destroyed those walls and crossed that barrier to reveal the room. So the core of what we're doing is right here, line 255, which is just setting the color of each tile and setting the alpha to 0. Now, to do this, we take our tile map, which is the hidden rooms tile map, and our collider, which is that box that we're using as a bounding box. And you can see that well, actually, let me jump to this real quick. So the set color, it needs two things. Obviously it needs the color, but it needs a point, a vector3 int. And this basically, wherever this point is in the world space, it will set the color for the tile that that point lands on, whether it's in the middle of the tile or in the corner of the tile, just whatever tile it hits, because one point can only land on one tile. So since we have a whole bunch of tiles, we want to do this. We don't want to have to manually list out all of the tiles. So that's why we're using that collider for the bounding box. So the problem is the bounding box is not a vector3 int. It's a vector3. So you can see right here we have the collider, and we're calling collider.bounds.min and collider.bounds.size. We're doing some other stuff, but I'll explain that in a second. So this is what we need to build, is the area that of all the tiles, and it's a bounds int. And a bounds int takes a vector3 int that is the position. This would be the minimum, and then the size, which is another vector3 int. So basically how bounds and bounds int both work is you give it a minimum, so that would be like this spot here, and then a size, and it would be an x, y, and z size. So it would be, all right, well, the minimum's here, the x is 5, the y is 4, and then obviously the z as well. So since we need that, we need the bounds min and the size. But since we need them to be vector3 ints and not vector3s, we're calling floor to int. And then for the size, in addition to calling the floor to int, there's another change, is I'm adding another vector3 int with a z of 1. And that's because all of my tiles are 0 for z. And if you take a look at this all positions within, which is what we're using down here, which I'll get to in a second, you can see for this bound, to get all the positions, it has 64 points, 4 times 4 times 4. The minimum is 0, the max is 3. But then you take a look, the minimum is 0, and the size is 4, because it's not, you can think of it as it's not inclusive, because that's the edge of the box, right? So this is going to give you 0, 1, 0, 1, 2, 3. So if you leave the z as 0, which is what this will return since all my tiles are 0 for z, once you do the bounds int for this, you'll actually get no tiles, because the 0 will not be inclusive, and it'll basically say, hey, you're going from z0 to z0. That's, there's no tiles there. So you have to go from z0 to z1 to get all this tiles on this 0 plane. Butchered that, but hopefully that made sense. So I just add that vector there, and I build the bounds int, now that we have these as vector3 ints. And now that I have a bounds int, I have every point that will tell us where all of these tiles are in this secret room, because it was built from this bounding box. So we just loop through all of those points by calling all positions within, which is this method or function. They can be called on bounds int, and since we're using a bounds int, we can call this, so all positions within. And for each position, we just set the color, the alpha to 0. The last kind of tricky thing is that you do need to set the tile flags for each tile to none. I googled this. I found it's not really explained that I saw in Unity documentation, but I found some posts about it. Basically, if you go here, and if you take a look at one of the tiles, I'm actually in debug. If you go to normal, you won't see it, but if you click up here and you go to debug, you can see the flags for the tiles. And by default, in Unity, the flags are set to lock color, which means you can't change the color. I don't know why this is. So you just need to set the color or the flags to none, and then you can freely change the color. I have this commented out because I saw some YouTube video that said that if you didn't lock it back, or re-lock it after you set it, then it would other tiles on your tile map that are using the same base tiles would also have their color changed. I tested that out. I didn't experience that, so maybe that was a bug and that's been fixed. But I have it here just in case I end up running into that issue. So this is all in start, so this is all just to hide all of those tiles by setting their alpha to 0, making them invisible. And then it's simply just doing as simple as doing the reverse. And basically all I'm doing is on trigger enter 2D if it's the player. So if the player crosses this edge collider, it's just on trigger enter, and I have these both set to trigger, so it's really if the player crosses any of these, but the only way they can get into this room is through this right here. So as soon as they cross this edge collider, they'll trigger reveal room, and then reveal room, it's very simple. Again, just loop through all the points within the bounding box, and set their alphas back to 255, which makes them visible again. And that's it.